Radioactivity is the natural process in which radiation is emitted spontaneously due to the decay of an unstable nuclide. It happens when an unstable nuclide continuously disintegrates into daughter nuclei until it reaches a stable configuration. Radioactivity can be both useful and harmful in the real world. That's why it is important to study about this. However, since radioactivity is a process that cannot be seen by the naked eye, it could be difficult for some students to understand this phenomenon. That's why multiple experiments have been developed to simulate radioactive decay. In particular, a simple experiment can be simulated in a classroom setting by rolling dice, which is called the radioactive dice experiment. The atoms of the radioactive nuclei is represented by a large number of dice, which are thrown simultaneously. Every dice showing any particular number n is deemed to have decayed. After each round of rolling, all dice that show the number n are removed, while the rest will remain. The number of remaining dice represents the number of remaining atoms of the radioactive nuclei that have not yet decayed for a certain time t. This process will be repeated until the number of remaining dice reaches about 10% of the initial number of dice. And by plotting the number of dice remaining versus the number of times the dice are rolled, we will be able to calculate the decay constant of the radioactive dice. In my thesis, called A Modification to the Radioactive Dice Experiment to Enhance its Decay Constant Approximation, I will be using polyhedral dice with 12, 10, 8, 6, 4, and 2 sides to simulate radioactive decay, and to observe whether using dice with more number of sides and increasing the initial number of dice to be thrown will decrease the discrepancy between the theoretical and experimental decay constant values.